Inside this lecture, I'm going to show you a small demo, and once this demo is completed, you're going to get a good clarity around inversion of control and dependency injection. With whatever discussion we have done in the previous lecture, it's all theory and you may have some burning questions. Let's try to smash all of them with this demo. I have created a simple Java project with the name Core Concepts. I'm going to upload this project into the GitHub repo as well under section 6. Inside this project under Java, I have a package with the name com.easybytes.coreconcepts, and inside this package, there are a good number of classes. Inside these classes, there is some small business logic. Let's not worry about how to build these classes, how to type this business logic. My intention is only to use this project to show you a small demo. In case, if you are interested to try the same demo in your system, you can get this project from the GitHub repo. I don't want to waste your time by typing all this code. That's why behind the scenes, I have prepared this small project. Inside this package, there is a class with the name vehicle. Think like I own a company like Elon Musk, and I'm trying to manufacture vehicles. Just like how Elon Musk manufacture and sells a Tesla car, similarly, I'm trying to do the same, and this vehicle Java class is going to help me. Inside this vehicle Java class, there is a method with the name makeVehicle, and inside this makeVehicle method, I have written some business logic. This business logic is going to attach some speakers and wheels to my vehicle, because as a vehicle manufacturer, I don't want to take the responsibility of manufacturing the speakers and wheels by myself. Instead, my intention is to outsource these speakers manufacture and wheels manufacture to some other famous vendor. That's why inside this makeVehicle method, I'm trying to create an object of Sony speaker. There is a class with the name Sony speaker inside the same package. If you open this class, it implements a speaker interface. And based upon the speaker interface abstract method, which is make sound, my Sony speaker method override the abstract method and implemented some business logic. The business logic is just to return a string value saying that sound from Sony speakers. Inside my vehicle.java, I have created the object of speaker and I have invoked the make sound method. Whatever output I am getting from this make sound method, I am trying to print onto the console. Similarly, to attach wheels to my vehicle, I am depending on the Michelin wheel. Let me open this Michelin wheel. This class implements an interface with the name wheel, which has abstract method moveVehicle. The same abstract method is overridden inside the Michelin wheel, and this abstract method, it is going to return a string which is moving vehicle with Michelin wheels. I hope you're clear what we have inside these classes. Now with the help of this wheel object, I'm trying to invoke the moveVehicle method, which is going to return the output, the same I'm trying to print onto the console. If you closely observe my business logic, my vehicle class is dependent on two other classes or two other objects. What are those dependencies? Sony speaker object and Michelin wheel object. Since I am trying to achieve everything with the help of core Java, me as a Java developer, I have taken the entire responsibility of object creation and injecting the dependencies into the class. Everything is taken care by me. That is what you can see here. I'm trying to create the objects. Why I'm trying to create the object here? Because my vehicle class is dependent on this speaker. Inside the same vehicle class, I have a main method to execute this method makeVehicle. Here, I'm trying to create the object of vehicle, and with the help of vehicle, I'm trying to invoke the makeVehicle method. If I execute this program, you will be able to see inside the console, I got the output saying that sound from Sony speakers, moving vehicle from Michelin vehicles. This confirms my application is working, and I can assume that my vehicle manufacturing is also completed. By the time this method is being invoked, we can assume everything else inside my vehicle is ready, like engine, seats, lights, glasses, everything is ready except speaker and wheel. Once this makeVehicle method is executed, my vehicle will be 100% ready and I got a successful response. So this is our scenario, and this is how it will be if you try to implement the business logic using plain core Java. Here, there is no inversion of control, there is no dependency injection, everything developer is doing. The control is completely with the developer. But with this approach, there are good amount of disadvantages. Let's try to understand what are those. In future, if you don't like using Sony speaker or Michelin wheel, you may want to go to some other vendor, or you may want to go with some other dependency. Just like how we have Sony speaker, I also have another class with the name Bose speaker, which is going to be manufactured by some other vendor. And on the wheels side as well, I have another class which is Bridgestone wheel. Let's imagine inside my vehicle.java, this time I want to migrate to Bose speaker and Michelin wheel. How to achieve the same? The developer has to get rid of all this code and he need to write new code again. This time, instead of creating the dependency with the name Sony speaker, he need to create the Bose speaker dependency or Bose speaker object. In the similar lines, the developer has to comment this Michelin wheel and he need to create a object of Bridgestone. I'm getting a recommendation, I'm pressing tab, and with that, I'm accepting the recommendation. How I am getting this recommendation? There is a plugin that I'm using inside my IntelliJ with the name Codium. Please install this Codium and it is going to give recommendations to you as you type the code. So if you see the pain point here with this approach is, anytime if there is some requirement is changing, the developer end up touching this vehicle class and this make vehicle method. With this, what is happening? There is a tight coupling between this vehicle class and its dependencies. If there is a change in the dependency happening, then the developer has to change the code inside the vehicle class. To some extent, developers, they try to solve this problem with some design patterns before Spring Framework. Let me show you how they try to solve this. For the same, I'll go to another class with the name Factory Vehicle. So this class, it is going to use factory design pattern to identify the dependencies and inject them. Let's try to understand how this factory design pattern is going to work and how it is going to solve our previous problem. Here the class name is factory vehicle and this class has a method with the name make vehicle using factory pattern. Here also we have a main method which is going to invoke this make vehicle using factory pattern method and we are going to get the output from the speaker and wheel. If you see here, this method this time it is using some other classes as dependency, speaker factory and vehicle factory. If I go to the speaker factory right now, they are trying to return an object of Sony speaker as a return object. So since Sony speaker implements speaker interface, though the return type is speaker, there should not be any problem. Similarly, if I open this wheel factory class, inside this, they are trying to return Michelin wheel object. The advantage with these factory classes is this factory vehicle class, it never has to know what are its dependent classes. It will only know that it has a dependency on the speaker and wheel, but it never has to bother about the vendor who is preparing the speaker or who is manufacturing the wheels. In future, if I want to change the vendor, the change will not happen inside this class. The factory class business logic will never be touched. It will always be like this. The change will only be inside the speaker factory. Here, instead of Sony speaker, this time the developer, they have to create the object of Bose speaker. This is how they are going to control the object creation inside separate entity called speaker factory. So here what the developer has done, the developer creates separate entity or separate classes like speaker factory and vehicle factory, which are responsible to produce the objects based upon the business logic. Since these factory classes, they are responsible to produce the objects, that's why this pattern is also called as factory design pattern. If needed, we can also enhance this factory class by accepting some input to this get wheel. Maybe I can accept an input saying that string vendor, and based upon the vendor, I can have multiple if conditions inside this method, and based upon the matching vendor name, I can create the corresponding object and return as an output to the caller class. I don't want to go deep into the factory design pattern, but I'm just giving a clue how a full implementation of factory pattern is going to work. With this approach, we solved one of the drawback or one of the challenge, which is if there is some dependency is changing or if there is some vendor is changing, this class will never be touched. Instead, the change will be inside some other classes. But still, we left with one more disadvantage, which is still the developer is responsible to create these objects like speaker factory and this Michelin wheel. And with that, what is going to happen? The developer will end up writing a lot of code. Whereas if you give this responsibility to frameworks like Spring, the developer don't have to create any objects. Dependency injection also will be taken care by the framework. With this factory pattern, we achieved loose coupling. That means right now it is not dependent on any specific vendor, the business logic is returned with the help of these interface references like speaker and wheel. Let me try to execute this class, and this time you're going to get the similar output, which is sound from Sony speakers and moving vehicle from Michelin wheels. I hope you're clear with this approach. Now I'll show you how this is going to look like with the help of Spring Framework. Let me open a class with the name Spring Vehicle. Do you see inside the Spring Vehicle, we are going to inject all the dependencies with the help of these auto-word annotation. For now, don't try to understand what is this component annotation, what is this auto-word annotation. Let's not worry about them. We're going to discuss them in detail in the coming lectures. I'm only trying to teach you how simple our code is going to be with the help of IoC and dependency injection provided by the Spring Framework. So as a developer, I just have to tell to my Spring Framework that my Spring Vehicle class is dependent on speaker and wheel. And how do I declare that? With the help of these auto word. I'm telling to my Spring Framework, by the time you are trying to create the object of this Spring Vehicle, please make sure these dependent classes are injected as dependencies into this class object. With that, what is going to happen? By the time this method is executed inside my Spring Vehicle, the speaker variable will have the object to reference of one of the implementation of speaker interface. Here, nowhere I'm trying to create the object of speaker or object of wheel. I'm straight away trying to use this reference. So at runtime, the Spring is going to take care of injecting the dependencies into the speaker variable and wheel variable. Do you see how simple this code looks? With this code, we are trying to give the responsibility of object creation and dependency injection to the Spring Framework. I'm not even going to write any factory classes like you can see here. Everything I'm going to hand over to the Spring, and I'm going to sit back and relax. The developer responsibility will always be to define the dependencies properly in such a way that Spring Framework can understand. I'm not going to run this class because to run this class, we need to make some other setup. Since we are yet to discuss about the setups and basics of Spring, I'm trying to avoid this right now. But in the coming lectures, definitely we're going to create these kind of classes and we are going to inject the dependencies and we'll try to run our programs. I hope you're clear with this demo.